Hello class, and welcome to another video lesson. Alright, today we're going to start out with chapter 6, section 5. We're looking at this is fractions, decimals, and percents. Oh my. We're going to be looking at how to convert fractions, decimals, and percentages back and forth. You should already know how to convert fractions and decimals. We've covered that. That's kind of old. But we're going to take a look at mostly how to convert these two in percentages and how to convert a percentage into both of these. So before that, let's go over some definitions. First, we need to look at the word percent. If y'all don't know, percent actually has two parts to it. It has the per and the cent. Cent, if you think about it, think about words that begin or have the word cent in them. When we're talking about like that root Latin word, like the word centurion or century or centimeter or centipede. Cent refers to 100. That's kind of why we call money cent, because it takes 100 cents to make $1. That's part of that reason. So cent stands for 100. Per is out of. So when you're talking about a percent, you're talking about a ratio where it's comparing something to a whole, which is 100. So we could say a percent is a ratio that compares a number to 100. There's an implication to that. Therefore, you can write a percent as a fraction with a denominator of 100. I'll show you what that means as we look at these examples. Here we have some directions. We're told to write each percent as a fraction and a decimal. So let's take care of the fraction part first. We have 5%. Well, I just read that I can write a percent as a fraction with a denominator of 100. So you take whatever the percentage is and you say 5 over 100. And that is your fraction. Now we will have to simplify these fractions. You could simplify it by 5, so to get 1 over 20, okay? So that's how you could do that fraction part of it right there. Over here, once again, you could take the whole percentage and put it over 100. So you have 375 over 100, okay? Now I know that this is improper, so I'm going to go ahead and turn this into a mixed number. So I'm just going to go and make my equal sign like this and go ahead and say that's 3 with 75 over 100. So that's my mixed number. It's real easy to do. So long as you have 100, basically anything in the past these first two digits, that's going to be your whole number. That's how easy it is. That's why I like converting it right now. It's a whole lot easier to turn to a mixed number. Well, I know that this can reduce to 3 3/4. All right, so those are my fraction parts of it. The decimal parts are even easier. What you do is you just write down this number, okay? And so this is one answer. That's the other answer, okay? For the decimal part, you just write down like 5, okay? You put a decimal right there where it's supposed to be for 5, and you move it to the left 2 times. Fill in any gaps with zeros. So this gives me 0.05, and that's how you turn it into a decimal. So this one, write down 375, put your decimal at the back, move forward twice. So this equals 3.75, okay? That's how easy that is to turn into a decimal. Let's look at a few more examples for some other ones. Example 2, write each number as a percent. So here we have 0.4, and over here we have 1/4. Let's take care of this one first. When turning a decimal into a percent, you do the same thing we did up here, but instead of moving to the left, you now need to move to the right. So 0.4, you could just say, okay, that's like 0.4, move the decimal over, move the decimal over, and you fill in with a 0. So it gives us 40 okay? That's all that gives us right there. Over here we have 1/4, and there's a few options you have. Okay, I'm going to show you two of the basics. One option you have is just to go ahead and divide, where you go and say, well, this is going to equal, I could do the long division to the side, 4 goes into 1, got to put my decimal, and basically you have the option to convert to a decimal. So 4 goes into 1, nope, 4 goes into 10, yes, goes in there 2 times, multiply back, you get 8. Subtract, you're going to get 2. Bring down another 0. 4 can go to 25 times, yay. So you get 0.25. Well, if I convert 0.25 into a percent, I would get 25%. That's one option, using the decimal. The other option is to use this little fact we just covered up here. If the denominator is 100, whatever's in the numerator, meaning if the bottom number is 100, whatever's on top is the percent. So is there some way I could change this fraction to get 100 in the denominator? Why, yes. If you multiply, if I had 1/4, and I times this by 25, and I times this by 25, I would get 25 over 100, which is equal to 25%, okay? You see, you can get it two different ways. One way is just to get 100 on the bottom, and that's good. Now, by the way, this method only works if the number in the denominator is a factor of 100. If it was like a 8 or a 7, 11, a 15, you couldn't use this fraction method. You can always use the convert to a decimal, then to a percentage method, okay? All right, let's look at two more examples just to make sure we understand. Okay, you can have percentages, like you saw up at the top, that are greater than 100. So as we convert this, you just notice what we get. So remember, we move the decimal back twice. So if we move it back twice, we'd end up with 401.2%. You're allowed to have a percent that is bigger than 100, and you're allowed to have decimal percentages. It's okay, you can have that. So this is the answer, pretty easy, just move the decimal. Over here I have 5. This is an improper fraction. You could convert it to a mixed number if you want to, or you could just divide, or you could get 100 in the bottom. I'm going to divide though because it's the method that works 100% of the time. So I'm going to say 5 goes into 7. 5 goes into 7 one time. Multiply back, you get 5. You subtract, you get 2. You bring down a 0. So you get 20. 5 goes into that 4 times. Okay, so I actually have, I'm going to put my decimal there, I have 1.4. 1.4 as a decimal. That's a decimal answer. That's not my percentage. If you convert that to a percentage, you would end up with 140%. So that's how you would handle that right there. So that covers the information we need from section 6.5, fractions, decimals, and percents. All right, we're going to look at another thing real quick. Not going to take much longer. Just look at 3 more examples from the next section, where we have section 6.6, proportions and percents. This is kind of the more practical use of percents. This is where we take proportions, which we've been using a lot of. We take the percents, we put them together, we solve, okay? So first, what we're going to take a look at is this right here. We're told to find 80% of 245. This happens a lot. Like maybe you find out that, like for instance, what happens if you find out that you need 80% of the students in the class need to make an A on the test in order for the class to have a party, and stuff like that. Or what if we found out that if like this is the number of students we have maybe in the whole high school building. If 80% of the students manage to make A's on their finals, the whole school gets a pizza party. Yay, pizza party. Exciting. So what we're going to do here is find out, well, how many students have to make that? If it's 80%, that represents the whole. That's the percentage. We have two little methods we can look at that would help us out here. One is this. This is called percent over 100 equals is over of. So if you have percent over 100, it equals is over of. Another way of looking at that is the percent over 100 is equal to the part over the whole, okay? Now you might not get what that means quite yet, but I'll show you what that means as we're working this out, okay? So let's take a look over here. If you look at this sentence, we're told to find 80% of this number right here. So this is the whole group. This is the percentage. I'm looking for the is. I'm looking for the part. Here's a better way to look at it that kind of just sticks with people. Go ahead and just make your little bars and put your equal sign and put your 100. The 100 always goes there. That 100 is representing 100%. It's representing all. Okay, that's what that stands for basically, all. The percent. Now, does the problem give us a percentage? It does. It gives us 80. Go ahead and put 80 above 100. Now, of, whatever comes typically after of, is the whole. It's the part that goes down here. You see how we have there of right here? Of goes right there. So we take 245, put it there. Well, I don't have an is anywhere in here. That's what I'm looking for. I'm looking for the part. I'm looking for the 80% of this number. So that's where I put my variable, x. At this point, it's just a proportion problem that's easy for you to solve. Just go ahead and reduce, cross multiply, and divide. So if I reduce this, I could say, well, 20 goes into this. You could slash that and say I got 4. 20 goes into this, slash that, I got 5. Cross multiply, divide, okay? So I could get 5x is equal to, well, what is 4 times this? So 4 times that would be 20. Get my 0. 4 times 4 is 16. Do that. 8. Got the 1. 4 times that is 8. The 9. So 980. So we had 980. Divide by 5. Divide by 5. So x equals, well, I know that 5 goes into 80 16 times. 5 goes into 900. It goes into 90. What is it? 18 times. And so it means it goes into, 5 goes into that 180 times. So that would be 100 and, what is that? 96. So that's your answer, okay? 80% of 245 is 196, okay? That's how we could get our answer for that. Next over here, let's set up our proportion again. What percentage of 40 is 30? What percent? So what am I looking for? I'm looking for the percent. I mean, do you see a percent anywhere on here? Nope. Well, that means I'm going to look for a percent. So I can go ahead and set up my thing where I have my percent over 100. I don't know my percent, so that's my x. Is equal to is over of, or part over whole. See, is over of. The is 30. The part is, sorry, the is 30. The of is 40. There we go. We could reduce and then cross multiply. You would get 3 over 4, cross multiply, and you end up with 4x is equal to 300. You could divide by 4, x is equal to 75, okay? Simple enough. Last problem we're going to do is here we have 310 is 50% of what number? Of what? Of what? We don't know the of. That's what we don't know. So we need to create our, once again, parts here, okay? So we have the 100. We know the percent this time. It's 50. We know the is 310, and we know that our variable goes here because we don't know the of. It's of what? So we could reduce to 1/2. We could cross multiply, and we would get x, because 1 times x, is equal to 2 times 310 is 620, and we're done, because that one worked out pretty easily with no dividing needed because we multiplied by the 1. So I want you to notice something. Notice that when we are looking for these things, x is in a different spot each time. If you're looking for the is, it's in this spot. If we're looking for the percent, it will be in the percent spot, and this time it's on the bottom. So we have 1 on the top over here, 1 on the top over here, and 1 on the bottom. The only thing that stays constant is we have 100 in the same spot each time. So this is the formula you use to solve these kind of problems. We'll go over more examples in class, and you also need to know that sometimes you can be dealing with, just like we saw before, percentages that are more than 100. So we will have examples like that in class. Just focus on learning the method that we showed right here, okay? All right, I'll see you then. Ta-ta, bye-bye. Ooh, creepy hands.